In this lesson, we're going to look at series circuits, and in particular, the current that flows in the series circuit. But first of all, let's just think what we mean by a series circuit. Now, we can take this illustration from the idea of parking cars. So, for example, here we've got two cars parked in the street, and they're parked in series. That means they're parked nose to tail. Along comes another car. It drives along, drive, and it parks again. It parks itself in series, right? Again, parking in nose to tail. Well, we can think about the same thing in the components of a series circuit. For example, these light bulbs here are being introduced in series to the circuit. They're being parked, if you like, end to end. Okay, and now what happens to the current in a series circuit? So I close the switch and a current flows in the circuit. Remember, it will flow from positive terminal of the battery to the negative. Okay, so in this case it will flow in this direction, in a anti-clockwise direction. So if I want to measure the current in a series circuit, then I have to connect an ammeter into the circuit, and I will connect it in series. That's to say end to end. So supposing I measure the current at this point of the circuit and I find that a current of 1 amp is flowing, say. So if I move the ammeter and position it in another place in the circuit, for example there, then I will find that the current is still the same. Still 1 amp is flowing. Or if I position it here, then it will still be 1 amp. In fact, it doesn't matter where you measure the current in a series circuit, the current is always the same. So let's state that. So the current is the same at all points in a series circuit. Now let's have a look at these other two circuits, for example. In each case I'm introducing light bulbs into the circuit, and these light bulbs are all identical. Okay, they're all identical light bulbs. They're all exactly the same thing. Now a light bulb really is just a resistor that gets very, very hot and emits light. So we can think of these as resistances. So what happens as I increase the number of light bulbs in the circuit? What happens to the current? Well, we will find that as we measure the current, as we connect the ammeter in series here, that the current is less than it was flowing in this circuit. In fact, if there was 1 amp flowing in this circuit, well, in this case there will be half an amp flowing in the circuit, because I've doubled the resistance. I've increased the number of light bulbs by 2. Okay, we can make a note of that. Let's just say if there was 1 amp flowing in that circuit, well, there will be 0.5 amps flowing in this circuit, because we've got twice the resistance. And if we measure the current flowing in this circuit, well, we'll find that the current will now be 1/3 of an amp, because I've increased the number of light bulbs, and these are identical light bulbs, by 3, and therefore I've increased the resistance by 3. So there's 3 times as much opposition to the flow of current in the circuit. So we could say in this case there will be 0.3, that's 1/3, let's just call it 0.33 amps flowing around the circuit. Now what does that mean for the light bulbs? Well, it means this will affect the brightness of the light bulbs. The lower the current, the less the light bulbs light up. So these light bulbs will be a lot less brighter than the single light bulb connected in series. Again, as we said before, just emphasizing this, that the current is always the same. So if I measure the current at that point in the circuit, it will be 0.5 amps. The same here, and the same here. The current does not change in that series circuit. Again, the same here. It will be, if I measure the current here, it will be 0.33 amps, or here, or here. So let's just summarize again. The current is the same at all points in a series circuit, and the current decreases as more light bulbs are connected in series.